All right, welcome back. We're going to talk now about the ketose sugars, those which contain a ketone functionality. All right, the smallest carbon chain, just like glyceraldehyde, does contain 3 carbons, and because this has to be a ketone, now that we're talking about keto sugars, um, you cannot have the carbonyl at position 1. If you did, you will never achieve a ketone functionality. Instead, you have to have the ketone in between your carbon chain, right? Somewhere in the middle. Now, all the sugars that I'm going to derive, the carbonyl will happen to be at position 2. Okay. And then this one right here, if you look carefully, you should realize that the left side of the ketone is simply a CH2OH functionality, and the bottom portion, I guess technically, is also a CH2OH. So technically speaking, this molecule is achiral. It doesn't have a chirality associated with it. And specifically, this is known as dihydroxyacetone, right? You have 2 hydroxy units at carbons 1 and 3 of acetone. So this is technically the smallest sugar, but there's no chirality associated with it, right? So you wouldn't call it dihydroxyacetone or dihydroxyacetone. It's just dihydroxyacetone, period. But when you derive the 4 carbon chain from this thing, right, you basically kind of have to do something similar to what we did with the aldose sugars. But here the point is that we're going to stick to the D sugars. So notice that on the penultimate carbon, I'm writing on purpose OH on the right side of the Fischer projection. The CH2OH that I have in condensed form right here is technically the CH2OH you have a position 3 of dihydroxyacetone. But here you're sticking the carbohydrate equivalent between what used to be positions 2 and 3. In essence, you stick the carbohydrate equivalent right after the carbonyl, right? So that's why this HOH is appearing right after the CH2OH at the bottom of dihydroxyacetone. And then after that, what we copy up here is what we had before, which was the ketone functionality followed by CH2OH. So there is ketone, and at the very top, we have CH2OH as the final functionality. All right, so as I mentioned to you, we're going to stick to these sugars for pretty much all denominations right here. So we're going to put the OH on the right side, and since that's the penultimate carbon in this ketotetrose sugar, this is a D sugar by default. Now, just to remind you of this, if you were tasked with drawing the L version of this sugar, you will have to first write the D sugar and then draw the mirror image of this thing. That will be the only way to get the actual true L sugar. All right, but aside from that, let's get about the names. Now, these names are going to be a little bit funky. They even funkier, you could say, than the aldose sugars. This one in particular is called erythrulose, right? So it gets a little bit fancier in terms of the pronunciation. And then just like what we saw with the aldose sugars, these things are going to continue multiplying by 2. So here we have the first and only D sugar of a 4 carbon chain, basically the only ketotetrose sugar that happens to have the D configuration. So from this thing, we'll be able to make the 5-member carbon chain of a ketose, but we'll have now 2 options, right? So what we do is we copy everything short of the carbonyl. So from positions 4 to position 3, I'm going to copy and paste those fragments exactly as they were in erythrulose. And at that point, what I do is I add the new horizontal line, which is where the new carbohydrate moiety is going to appear. And after that, or above it, is where we have the ketone followed by the CH2OH, right? So this is how you extend the chain of your keto sugars. Your keto pentose sugars in this case. All right, and then all you have to do is simply go through the 2 modalities, right? So on the left side, I'm just going to put the hydroxyl to the left. On the right variant, I'm going to have hydroxyl to the right. And these 2 D sugars have their own names. They're both deriving from erythrulose, but because of that one difference, that epimeric difference, these 2 sugars have different names. The first one is called cellulose, And the last one, or the one on the right, is known as ribulose, right? So don't confuse ribulose with ribose. I know the names are very similar, and xylose, it's very similar to cellulose, right? But they are they're different families and different sugars as well. Okay, so we have two keto or pentoketose sugars. So we now can extend this to the 6-carbon chain. So what we do is from carbons 5 to 3, basically falling short of the carbonyl, we just copy what's below the carbonyl exactly as is for cellulose. And we do the same thing for ribulose, right? We copy everything below the carbonyl exactly as is. Then we acknowledge that we're about to extend the chain, so we'll have one more horizontal fragment presenting here. And then above that horizontal fragment is where we finally will have the ketone followed by the CH2OH, right? So now we have 6 carbons in that entire vertical portion of the molecule. All right, and then we do the same thing we did before. For one iteration, we have the hydroxyl pointing to the left. For the other iteration, we have the hydroxyl pointing to the right. And this gives you all 4 derivatives of your ketohexose sugars. So, or hexoketose, if you want to be technical about the denomination. All right, so all these sugars, which derive ultimately from cellulose and D-ribulose, are also going to be D sugars. So we simply use, I'm going to show you the names, right? So the one where we have 2 to the left and 1 to the right is known as tetroketose. The variant where we have 1 to the right, 1 to the left, 1 to the right is known as sorbose. The other variant where we have 1 to the left, 2 to the right is known as fructose. So that will be one to probably remember. And then the last one, which kind of has a funny name, it has 3 hydroxyls pointing to the right. This ketose sugar is known as psychose, right? Which it's kind of a funny name, but I don't know who came up with it, but I can tell that they were psyched about naming that sugar. So that's basically all your ketose sugars. And the next part is going to be a little more involved. So I will probably stop this particular video a little bit short because I want to focus entirely on the next video just on coming up with these Haworth projections and the chair conformation. So I'm going to save that for the next video. And that means that we're going to stop right about here. So I'll catch you on the upcoming video. Bye-bye.